The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Now, as you can see, the examples that we have on this page are a little bit more interesting. Reason being, we have multiple functional groups in the structures of these molecules. So I'll just direct your attention to the top left-hand corner of the screen. As you can see in this case, we have three functional groups. You have hydroxyl group right there, chlorine atom functional group right there, and a fluorine atom right there. Now in this case, knowledge of orders of priority becomes important, and if you understand your basic organic chemistry nomenclature, you will be able to know that the hydroxyl group takes precedence or is considered to be more important in naming than the halogens. So in this case, what's going to happen is those two halogens, chlorine and fluorine, will be treated as substituents. So you want to number the chain to give the hydroxyl group the lowest possible number. So obviously that would be moving from left to right to make that carbon number 1, number 2, 3, and 4, number 5 being the last one right there. In this case, as you can see, the hydroxyl group is attached to carbon number 2, and the chlorine substituent to carbon number 3, and the fluorine substituent to carbon number 4. So let's put all that information together. Okay, it's a 5-carbon compound. It's an alcohol, which would make it pentanol. Okay, we'll drop the E and add it all in a 5-carbon chain. That becomes pentanol. Now you also have substituents at position number 3 and position number 4. Okay, so you have to include those in the prefix of the name, which makes the name of this compound very simply 3-chloro-4-fluoropentan-2-ol. Okay, I'm just going to write that out for you. Becomes 3-chloro-4-fluoropentan-2-ol. So that's very simply the name of that compound right there. And in this case, what I want to point out is that we identified the position of the chlorine atom, we identified the position of the fluorine atom, and the fact that it's a 5-carbon chain meant that it became a pentanol. The hydroxyl group is located on carbon number 2, and that's where that 2 comes from right there. I'm just going to add a hyphen. And there you go.